Tilford. I'm from the Visual Studio team, and I'm going to talk about the new editor in Visual Studio 2010, which is going to be in beta real soon now. So it's a whole new code base written in C# with an all-new API. It has nothing in common with the old VSIP editor interfaces. We put it together using the Microsoft Extensibility Framework, MEF, which is another new feature coming with at the same time as Visual Studio 10. It's an extensibility framework, a dependency injection framework, if you will, that we're using to put it together. So we've embraced a philosophy of pervasive extensibility in this editor. We have done the right thing of using our own extensibility interfaces to build our features. And so it's quite a lot more flexible than its predecessor. And in fact, it's just a collection of MEF parts. There's a lot of different extensibility dimensions. I'll talk about some of them today. One of our objectives is to make it a lot easier to write language services, and in particular reduce the cost of entry to write a simple one, and at the other end of the scale to make it much easier to incrementally change an existing language service, either because you have a derived language or you just want to add a few features, and those kinds of things weren't possible before. Although this editor is new to VS, it's been around for a while and it's been shipping in a variety of hosts. In fact, you just saw a demo of it in the last talk in the graphical PowerShell context. It's also been shipping an expression blend for a couple of releases, an app called IntelliPad that you'll probably have heard about, and various others. So I'll start at the top with the presentation layer. This is a WPF app, so we get the power and flexibility and composability of that platform. It's very easy to host this editor and whatever UI you might have lying around inside Visual Studio. So for example, in addition to hosting it in document windows, you can host it in tooltips or tool windows or anywhere you want to present program text with the coloring and features of the language services. For the first time, we've got a VS editor that supports multiple font faces and sizes thanks to our use of WPF. And in fact, not only can you have multiple font faces and sizes in a single document, but you can have multiple contributors determining the formatting of the text. And the editor will merge those together. So a simple example is if you wanted to change the coloring of, say, comments because you've got some little language written in structured comments. Okay, that's one example. Another example is as a language service, you might have different processes calculating information at different rates, and you want a fast lexical coloring that is synchronous, a slower semantic coloring that is asynchronous, or an even slower analysis that takes a long time and wants to be asynchronous. So those can drive different providers of formatting information, and the editor will put them together for you. And a much wanted feature, we got zoom. But the most important way you can affect the UI is the thing we call adornments. And adornments are simply WPF UI elements that you can cause to be rendered by the editor with your text. And the way you do that is to create an adornment layer, which is a WPF canvas that's coincident with the viewport, has the same coordinate system as the viewport. There's a stack of these things. You can order them, so you can position your canvas above or below the text and also relative to other adornment layers. And then once that's done, you can associate UI elements with the editor by putting them as children of that canvas. The editor supports three fashions of doing that, three methods of positioning these things. The first one is text relative. So you take your adornment, you associate it with some span of text. When that span becomes visible, you draw your adornment on your canvas. And from that point on, the editor will take care of translating it as scrolling happens and editing and so on. So you can sort of fire and forget. And when the text is no longer visible, it'll get disposed and you're done. A viewport relative adornment is very simple. It's like a heads-up display. It's something that's fixed with respect to the viewport. Or finally, you can opt out of all help and let the take complete control over how you position your graphics with an owner-controlled adornment. So here's a picture. I don't know how well it shows, but there's stripes on that background. Some people like those. Those are each adornments associated with their respective lines. So, 75 lines of code to put that together and maintain it efficiently as the text changes. Another thing that comes up a lot when you're trying to put pictures on the screen is finding a place to put them. And so we provided this facility called space negotiation to allow you to do that. And effectively, the idea is to create white space in the text view for you to put your graphics without actually modifying the text so that processors processing the text aren't affected. So here's an example where we have some ad hoc outlining going on. Some text has been collapsed there and replaced with that thing with 3 dots on it, which is an adornment. So I'll talk later about how the text is caused to go away, but from the point of view of the text view, there is no text between here and here. And so this adornment is using space negotiation to create some horizontal space in which to draw itself. Similarly, you can create vertical white space, so you can separate lines and have room to put some sort of interesting UI. Here's a picture showing some IntelliSense going on. There's a completion list and some parameter help. And this is an example where you have multiple adornments competing for surface space. They don't need to move the text, but they don't want to be on top of each other. So they can talk to a broker which will allow them to negotiate for available space without having to know about each other. And others can play in that game as well. Okay, so since this is a language gathering, I should say something about IntelliSense, by which term in the editor team we mean those 4 features of Visual Studio that are helpful in composing code. Each of these we have an implementation of a default user interface for, and using a simple MVC pattern. And you can plug into that at any level, at the data source level for the data that's going to be displayed, and that can be done incrementally. So you could incrementally add data on top of some other language services, IntelliSense, if you wanted domain-specific information. There's default presenters that you can configure in various ways or replace completely, and similarly the controllers. The last thing I'll mention for UI extensibility are margins, which are what you think they are. 4 sides of the viewport contain 4 predefined margins called top, bottom, left, and right. You can add margins and you specify the parent of them, and they can be parented by these margins. Specify the relative order within their container. The margins you create can be containers. So container margins can, sometimes it's interesting to share behavior and control layout of their children and so on. So those are some of the examples of margins that we've built using this particular extensibility point. So here's a picture. There's a margin on the right, a sort of a document overview margin that someone put together. That's actually not a zoomed out text view over there. I don't think that would probably be the best way to accomplish this particular effect. Okay, last I want to talk about the text model at the bottom where we represent text. So our text buffer uses a functional style, and by that I mean that each microversion of the buffer generates an immutable snapshot of the entire contents of the buffer. This is really handy if you have a compiler and you want to do background processing on a stable copy of your text without locking. And in fact, this capability hasn't previously been available in Visual Studio, and language services have been forced to keep a separate copy of the text that's in the editor and incrementally update it, or worse, copy the entire buffer every time it changes. So there is, of course, an eventing model at this level, and the change events that you receive deliver you a before and after snapshot and the set of changes between them. The buffer supports multi-part discontiguous transactions that take you from one snapshot to just one more. And there's a whole menagerie of support classes and types that are common in this sort of domain to track text as things change and so on. The point I wanted to make about those is that they use lazy evaluation. They don't use locks. They're very efficient, which is a step forward from the previous editor. A number of other features at this level. I'll just mention that you can denote certain regions of text as read-only. That's convenient when you're building a REPL processor or something like that that you've seen. Also at the text model layer, we have this notion of projection of text. A projection buffer is a text buffer whose text, rather than storing text, is defined by a sequence of text spans from other text buffers. So you can use these to aggregate text from different sources, from different documents, for example, or to subset the text from a single document, or any combination of these. And because these things are text buffers, they compose so you can build stacks, so you can build DAGs of these projection buffers, which actually turns out to be pretty useful capability. So some of the applications of that are outlining to do subsetting, processing of embedded languages. Now, this isn't a new idea particularly, but you can extract the text of an embedded language into a different buffer, present it to that language's compiler, it sees it in isolation, isn't aware of the surrounding context, and then project it back into what the user sees. What's nice is that the coloring, the IntelliSense, the analysis, all of the adornments can be dealt with in terms of that extracted projection buffer rather than in the other context, so it's easier to build those kinds of systems. And the existing visual, yes, sir? Oh, I think I have a minute. A couple other applications. An interesting one we've barely scratched the surface on is using projection to hide text and then an adornment to present an alternate presentation. So you can imagine math editor or nice presentation of dot comments and all sorts of interesting things. We built one app that presents a live differencing session kind of in the WinDiff style, whereas a line is changed, you see two copies, the old and the new. But because it's using projection, you get correct coloring, correct IntelliSense, correct analysis, and so on. There's analogs to the tracking types I talked about earlier that map through projection space, just like those things track through version space. So there's another screenshot of a dot comment adornment where there's some dot comment there with XML markup. It's been projected away using projection. A space negotiating adornment replaces it with a nice presentation, and you could imagine building a documentation editor inside that adornment that was much more fun to use than XML tags. Configuring the editor, a text buffer has a content type, and you can read this slide, but effectively content types are related by inheritance, and this gives you a lot of flexibility in sharing components across different applications. Text views have roles. Those two things kind of define which extensions run. We do implement the old VSIP API, almost all of it. We have very significant language services running with very little change. The performance characteristics are actually somewhat different in this world maybe because they're now dealing with interop where they weren't before, or they're suffering from some of the semantic gap that we had to fill in. But any questions?